This lesson will cover Big Idea 2, Standard 3, and the topic for today is properties of metals, nonmetals, and metalloids. So the first thing that I want to talk about is the difference between physical and chemical properties. A physical property is a characteristic that does not involve a chemical change. A characteristic that does not involve a chemical change. An example of a physical property would be the appearance. If we had an unknown and we observed its appearance, the unknown is shiny, the unknown is silver. That is a physical property. Another example would be like boiling or melting point. Water boils at 100 degrees Celsius. But if I have liquid water or water in the gas state, it is still water. It does not involve a chemical change. It is just changing its state of matter. Another example, conductivity. Does the unknown conduct heat or electricity? Think about like a pan when you're cooking. That metal gets hot. It is a conductor of heat. Another example, malleability. I always think of malleable like moldable. Things that can be molded in different shapes, we say they are malleable. So if you had a metal that was like a sphere and you were able to hammer it into a sheet, flatten it out, we would say that substance is malleable. And again, that would be a physical property because it's not involving a chemical change. We also have things that are called chemical properties. A chemical property is going to have a chemical change. A chemical property will determine whether a substance can react or not. Or we can say a chemical property is a characteristic that does involve a chemical change. Things that would be considered chemical properties would be like flammability. Is it flammable? Does it produce a chemical reaction? So if we put the substance in a certain chemical, like an acid, is it going to produce a reaction? Changes in pH, all of those would be considered chemical. So what we're going to do today is talk about the physical and chemical properties of metals, nonmetals, and metalloids. So first, let's do a quick review of where we find those elements on the periodic table. So notice the dark black line that is running through the right side of the periodic table. We call that the staircase. Elements that are on the staircase, with the exception of aluminum, are going to be the metalloids. So notice that any element that touches the staircase on both sides is considered a metalloid. Aluminum does touch the staircase, but aluminum is not a metalloid. So again, metalloids are down the staircase on either side. The elements to the right of the staircase are going to be the nonmetals. So all of these elements to the right of the staircase plus hydrogen. All the elements in pink are the nonmetals. Everything else on the periodic table, everything that I just left with the black border, represents a metal. So metalloids run down the staircase. Nonmetals are to the right of the staircase plus hydrogen. Everything else on the periodic table, including all these elements down here, are metals. So let's go through our properties. The nice thing about these properties is all you have to do is learn the properties for metals. Non means like not. The nonmetals are going to have all of the opposite properties. So we say that metals are lustrous, or they have luster. This is just a fancy way for saying that metals are shiny. Whereas nonmetals are not lustrous, they're not shiny, or we say that nonmetals are dull. That's something that you should be familiar with. So the only metal I have near me right now is my ring, but if we look at my ring, it is made of metal and we can see that it is shiny, so it is lustrous. Next, metals are good conductors of heat and electricity. So that's one that we've already talked about. Metals get hot. If you are heating up metal, if you're cooking, or if you leave your keys outside on a hot sunny day, that metal is going to get hot. Metals are good conductors of heat and electricity. Nonmetals have the opposite property. So if metals are good conductors, that means nonmetals are going to be poor conductors. All right, next, metals are malleable. And again, I like to think of malleable like moldable. Can we mold it into different shapes? Malleable means that the substance can be hammered into a sheet. Metals are very moldable. We can form them into different shapes. If metals are malleable, nonmetals are not malleable. We would describe the nonmetals as brittle. If you were to take a hammer to a non-metal, it is going to be brittle. It is going to break into a bunch of little pieces. Metals are also ductile. And what that means is that metals can be drawn into a wire. So think if you've ever seen like copper wire, we can draw metals into a wire, meaning that they are ductile. Nonmetals are not. Next, let's look at a chemical property. Our metals are going to react with acid. If we were to put a metal into acid, we are going to see some form of chemical reaction. It might produce gas. We might see that it starts bubbling. It might have a temperature change. We might see a color change, but we're going to see some type of reaction with acid. Nonmetals have the opposite properties. Nonmetals do not react with acid. Lastly, most metals are solid at room temperature. And again, that's one we should be familiar with. Think about the metals that you're familiar with, the metals that you may have in your home. Most are going to be solids at room temperature. Things are a little bit trickier with our nonmetals. Most are actually gases at room temperature. But some are solid or liquid at room temperature, but most of them are going to be gases. Lastly, we haven't talked about the metalloids. So notice where we find the metalloids on the periodic table. The metalloids are found between the metals and the nonmetals. So that means the metalloids have properties of both the metals and the nonmetals. So let's say you had an unknown that was lustrous but brittle. That might be a metalloid because it has properties of both. Maybe it is lustrous and it's a good conductor of electricity, but it's brittle and does not react with acid. So if you are doing observations and you're performing some of these tests on an unknown, and it has some properties of metals and some properties of nonmetals, it is probably a metalloid.